We're back. Where are we? Okay. Basically, got our load banks made up. Maybe I should zip tie these capacitors together so they stay. They keep falling over on me. Let's just wrap a big zip tie around them. Not quite long enough. Let's try this one. I think I have some jumpers in here I could use instead of my leads, but there's a good one. That's all I needed, huh? It's just the one. So I'm gonna pick yellow for these capacitors. Oh, so the plan of this video is basically to connect a bigger load and test that. Oh, Positive Peak, you're still awake. So, we're going to test a bigger load. And see if that changes anything. We're also going to hook up these analog these analog amp meters. We're going to see if that changes anything. And then what I also want to do, remind me, I want to change and run a bank of incandescents in a different way. I'm going to put the banks over here. So they're sort of out of the way here. Were you here earlier? Watching what I was doing? Probably not. I shouldn't wrap this like this. Okay, anyway, I really should put these on a terminal block. Let's ignore them for now. Yes, somewhat, he says. Okay, just wondering. So let's get our coil back over here. Had a little nap. Yeah, I wish I had a little nap. Alright, so this L1, this L2. This is the short. So actually, let's go ahead and put the coil back there. Our thermometer over here. And what I want to do is I want to be able to get this, actually, this particular camera in a good position to read these meters. Really, I should put the wide-angle camera down there, but anyway. Can I even get them? I can get them about there, but I don't know how well. I have to make those bigger, I guess, but let me, I mean, this is fine. This right here is fine. We can see all those, right? I don't know if you'll be able to read them. Oh, you should be able to read those, though, right? I should probably zip tie these all together, too. I guess this is an okay position for this camera. Almost be better if it were a little bit different, but just remind me to move this thing around if something goes silly. Okay. So I'm gonna actually, maybe I'll stick this in this corner for now. Actually, if I did that, then I could put them like this. How's that? It's not bad, right? So I should make my clock bigger though. That's not so bad. Let's thinking about zip tying these meters together. I think I will. Just so they never get out of whack here. Because I have to also get the scope shot on there and a bunch of other crap, so let's just go ahead and zip tie these. I'll get the camera set back up again later. This is VA. We'll pull some on this side. So how you been, dude? I'm glad you came because I was getting really bored by myself. Everyone else left me. They were tired. A humbug. I'll get something done. You can't sleep. Let's see. Okay. Yeah, I'm talking to you. I ain't talking to nobody else. There ain't nobody else here to talk to. I'm in a shed by myself. Everyone else is tired. You go to sleep. Bah humbug. Oh, we got another one. I lied, you're not the only one. It's gonna be a nice little panel meter when I'm done. Oh, you mean I don't have one more blue one to make my color scheme match? Oh, I do have one more. No, maybe not. Oh well. It's gonna bother me. Everyone's gonna make fun of me because the color scheme is wrong. Another live body, yay! Now what I should do is permanently wire some stuff on the back side of these meters. Just make it easier. Alright, so it'll basically look like that, and let's snip all these off. No red and white. Okay, that'll make it easier for things just to stay in place. Oh man. Now, volts and amps. So volts need to go across, amps needs to go through. So we're going to take this, which is our amp power. Okay, so we got power coming down, and we're going to go power into there, and we're going to go ground. Let's go ground down to here. Yeah, okay, ground. guess I should put you back this way anyway, because you guys need to see the load. Okay, and then we got our current probe right here. We've got our oscilloscope probe right here. One thing we need to do is take a power measurement and a CM spot. Clamp that there. Now I need to change, let me pull up the scope cam. I'm going to go ahead and make this a little smaller than, actually that's not bad right there. Remind me to get all this configured later, but at least you can see what's going on for the moment. Alright, I know it's hard to read, but we need to change this to a times 100. I also want to put these on DC. I want all these on DC. DC, 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 DC. Now what we also want to do, let's get this probe down. This is my other one. You know, this little shop is pretty neat. It's a freaking shed that I didn't put together and it's falling apart. And I am quite comfortable in here. It's like not awesome, but not terrible. It's like it's just enough space that I can like actually set up a project, which in itself is fantastic. Anyway, some things are pretty nice when you don't know what you have. So we need to set both of these I don't know. It's got a USB port on the back, I think, and I can do a lot of random crap. I think it's even got a computer thing, but I guess you guys can see those meters okay. They're not the best, but I have to turn this light off over here in order to get the scope to read nice without a reflection. And actually, I think if I turn this light on, I'll leave it off for now. Alright. I need to adjust the color though, because you can't read that very well. I'm just going to go ahead and default this. Change the exposure down a little bit. Let's try that for now. And if it gets all messed up, you just tell me. I think that's okay. Oh man, I changed both those. See, I hate that. What's that do that for? Because you change one and it actually, yeah. It's actually changing both of them. Well, the only way to fix that is have another external light. Let's see if this light still works. Well, wait, maybe actually. Well, you know, let's see what we got. It's gonna have to do. That's not great. Well, crap. What are we gonna do about that? Maybe this phone's actually enough to... Let me try this. It's just a no-go, guys. I guess we're gonna have to just... Let me try turning this off true color. So maybe actually this will change them separately now. I'm going to turn off the autofocus because otherwise it's going to keep wigging out. So that looks good. Let's see if we can configure the other one without messing it up. It looks like it worked. I had to turn off the true color function thing. No, last time it was more important to see the scope, I think, so I think we're good. We can individually set them now. I had to turn off a function apparently. I mean, can you actually read the scope? I'm having a hard time telling if you can actually read the scope. Let me make it bigger. And then turn the camera to the corner a little bit. Like that. And I can move it over a little bit. Now, maybe I can switch these because I think I want the load bank to be in the video. Okay. Alright, well let's call this good and let's move this back over here then. I want to make sure the scope is the best of the shots. But these meters are very important for this test, so... Okay. So let's go ahead and set these probes I want to make sure these are set to 0. So let's go to channel 4. Oops, I'm on channel 4, okay. Alright, I'm happy with that. Now, display, acquire, measure, save, recall, auto range. Okay. Let's go ahead and go to the power analysis. You guys can read all that stuff just fine. So we're going to clamp the ground on the ground here. The positive on the positive. Okay, the clamp on there. And then what we're going to do is connect all this stuff up. So we're going to be coming into the current probe, or into there. Okay, and out into here. And then voltage is going to be across those 2 points. So let's just use white wires for that. And I'll set this up once I get everything connected. Just bear with me until I get to that point. Okay, that's those meters. Now let's do the output. So we're going to go from, so this is L2 short, this is the L2 input. So we're going to go from here. We're going to connect this to the amp meter. We're going to clamp the amp meter on there, and this on there, ground on here, and then let's just hook up the voltage. So we're going to say voltage across this coil. I need a black wire to come out here. This on here, and then this is power out. Actually, put that across this wire. Okay, so this is power out. We need one more. For the voltage. And then we'll test this with no capacitors just to verify we have this all connected correctly. Okay, it's a mess. It's a mess. You can read it. So let's just hook up one of these banks just to have a load. Okay. Turn our amp on. Turn our volume down. Okay, we're at 1 kilohertz. Clipping. Okay, because we're all the way down. I'm going to bring this back up to 10 kilohertz temporarily. camera moved. Oh, sorry. Thank you. That's why you're here. There you go. Okay, and I may bump it again, so you just have to turn our trigger down. There we go. Okay. What I want to do is try to always keep everything on the same scale. I'll go backwards. Let's see, how can we switch that? The best way is to probably do this. Okay, now let's see what the other channels are reading. Okay, our LEDs are dead. Okay, so let's turn this down. Turn the output off. Let's connect our capacitor across the load. We're getting no LEDs lit, of course. We've got one bank of lights. Now I'm going to go ahead and bump this back up to 17.5 because I know that's where I want. Okay, turn the output on and go up nice and easy. There we go. Okay, now our LEDs are lit. And let's see what our analog meters are saying. Let's go ahead and just turn the mess around with this to see what happens. So I'll read the negative value again. I need to invert this. Okay, now we got same wattage. So let's try to tune this in because our load is a little bit different now. Oh, there we go. Alright, 25 watts. That's 18 watts. Power factor is 7. Power factor is 8. So actually that's a really good transfer of power right there. Wow. Let's stay late to test it. Yeah. So look at that. You know what? That's the result. Right there. You're seeing it. This is voltage out and amperage out. This is voltage in and amperage in. You can clearly see. I need to actually make sure this is lined up with the camera because it'll throw everything off actually. You guys have to remember that. You're looking at an angle. Is it blurry? Let me try to make it clearer. Focus. There you go. So what you're seeing is, okay, not quite an amp at not quite 50 volts, or actually a little over 50 volts out. Input is a little over half an amp and a little about 26 volts. So there's there's your over unity result right there. Okay, The meters are absolutely showing it. Just really interesting. So now let's add another load. Okay, I'm going to go ahead and use extra jumpers because I don't want to short anything out on accident. Move these jumpers out here, it's difficult to get to. So let's go ahead and hook up another load. And actually, I think what I want to do is hook these up not in parallel, but actually in series. So let's just turn the amp off so I don't blow anything up. And we're going to go basically here into there, and then here into here. Now we're basically two loads in series. Let's turn it on. Now we've got 2. Okay, and our amperage went up. Our voltage went up. That's it. This is the exact phenomenon. It's exactly right here. It's really interesting. Look, the current is in phase. See, there's where you lie. There's where it's all messed up. Okay, actually this would... True power, it says the input is 30 watts and the output is 21 watts. So let's try to tune this again. Alright, let's try to tune it with... I'm going to go big steps here. I want to see if I can hit a harmonic. Oh, I better be careful, I'm going way too high. Okay. You see the phase changing though. This is actually better. So what we want to do actually is sort of find the point where our power output is the highest. Just like right there. And our input is... Okay, so actually the scope is showing the wrong result or the proper result, and the analog meters are showing an over unity effect. So alright, so let's go ahead and try hooking these instead of in series, in parallel. Let's hook these back in series. And then we'll add the third bank. Right now we're going to add these in parallel. The load is now in parallel. Turn this guy back on. Now our input wattage is lower. Let's get it tuned in. And our analog meters are almost identical voltage in, voltage out, which is interesting now. So this is actually a not helpful thing at the moment. Let's turn this down a little bit. Mind telling me the color line representing? Okay. Yellow is the voltage going in. Blue is the current going in. Purple or pink, purple on this screen, is the voltage going out. and green is the current going out. And actually, yeah, just verify. Okay, those are okay. That's times 100 amps per volt. We want 100. So, whoops, no, cancel. Oh well, I'll have to reconfigure this now. I hit the wrong button. It's fine though, I just want to put all these back on the same. So what I got here is I'm putting voltage and voltage on top of each other, and then current and current on top of each other. Okie dokie. So interesting. So let's go ahead and add. I can tell those bulbs are definitely not full brightness, but let's go ahead and add the last load on here. Quite sure why those didn't light. Maybe it's not enough voltage. There they go. So let's try tuning these in. Very interesting. It's like adding them all in parallel really don't help. You can see the frequency down at the bottom corner, by the way. Don't forget I'm tuning with these capacitors, so what we can do is let's jumper some of these caps out. Let's just put one cap on here and see how it reacts. So that's going to change everything. No, they're all AC meters. The analogs are AC. You can see by the beautiful ripple on there. Okay, so now we got one capacitor, and our resonant frequency should be a lot lower frequency, so look at that current. Oh crap. Yeah, we're like a couple amps in. I gotta keep track of this temperature too. Now I'm dealing with high power. See, look at that. Over unity, baby! I got an amp. Well, let me tune it low so we can get exactly. Okay, an amp and a half in, 2 amps out. 48 volts versus 36. Like, like that's the phenomenon. But let's take a good look at the wave pattern here. Okay. So we're putting 50 watts of true power, 0.96 power factor, and 14 VAR reactive power on the input. On the output, we're getting 18 watts, 30 VAR, and only 0.5 on power factor, because the phase angle is different. Oh, and we're not even lighting up all the light bulbs. Strange. Only some of them are lit. You guys can't see that, but I hope I didn't burn the other ones out. Nope. Yep, see, some of them are popping on now. It's just not high enough voltage. So those are in parallel. Okay. Let's try adding let's try adding 2 capacitors. Now we're up to 3. Now we should be at a higher frequency. There we go, and now all of our bulbs are lit, so we have to have a higher voltage as well. So let me go to measure, because for me it's easier to see all of them at once. So let's go ahead and put channel 1 peak to peak on the first one. We'll put channel 3 peak to peak on that one. We'll put current on the second one, and current on the third one, and then RMS voltage on the output. Okay, so now what you're seeing is voltage input, voltage output, current input, current output, so we can get a really good reference of what we're seeing on peak to peak values. So if I try to tune this, now I can try to tune this a little bit easier. And what I also wanted to do is see if I guess I need to use RMS values if I really want to do this right. Let's just pick everything to be RMS, because I want to find out if our analog meters are reading correctly. So now we're all RMS voltages here. So let's get these values to read on the scope like 1 amp, which they're really right at 1 amp. Okay, right at 1 amp. Both of them are pretty darn close. And our analog meters, they're a little off. All of our lights are lit though, so we got good voltage over there. Okay, I'm going to actually disconnect a couple of load banks. It seems to work better with less load banks. So let's take that one off, and let's take this one off. Okay, now let's turn this stuff back on. I'm getting very tired, by the way. It's almost 1 o'clock. I should go to bed. So now we got one load bank and only 3 capacitors. About right there is resonance, and you can see the voltage phase change. You see that? That voltage phase change is the problem. And look at the voltmeters, okay? The amps and voltmeters are all showing an over-unity effect, right? But if we look there, well, actually the RMS value, why is the RMS value different? So it's only showing 25 volts. But this meter here is actually showing more. Let's try switching these leads and see if anything changes. In case we have some difference here. It's possible. Didn't change much though, huh? But you see the phase angle change on the scope there. The current is pretty well the same, but the others is not. So, I'm gonna try disconnecting the lights, because now our voltage is way up. Wow, there you go. Look at that. Can you guys still see the meters okay? Check that out. So that's with no load. That's purely just the capacitors. Look at that, yeah. That's the capacitors. See, there's your over-unity effect. It's actually just a resonance phenomena. Okay, but look at the meters, man. Look at them. I'm showing at 2.5 amps out. Our coil is still staying fairly cool. We're at 100 volts out. We're at 2 amps in and less than like 25, or we're at like 25 volt in. And oh, my trigger's all messed up. Let me switch the trigger. There we go. So there you go, 13.7 watt in, 38 watts out. But power factor is only at 0.37 on the output, and it's at 0.845 on the input. So reactive power is 8.45 on the input, and on the output it is 96. And the meters, these meters are showing the same result. But this is just purely the capacitors and resonance. So let's go ahead and add all the caps back on. I know this works pretty well that way. Okay, let's turn this back on. Let's tune this back in. About 17.3. No, the target is actually 1 power factor. We want a power factor of 1. So right now we're at about 100 volts, 2 amps. Let's not worry about the scope. Let's look at the analog meters. Let's try to tune this thing in. get maximum voltage and current out. Halfway to go. A power factor of 1 basically means you have true power transfer, like efficiency, really high efficiency. But look at the scope. Let's go back to measure, okay? Look, if we just were measuring and we didn't have that power analysis, look, we've got 8 volts in, 53 volts out. That's RMS. 2.5 amps out and 1.9 amp in. Yeah, there's your over unity. Boom. And the analog meters, they're still not very well. 1.5. Well, they're all right, but these aren't very accurate compared to my scope probes or something. But that's just purely the transfer of energy. That's truly the transfer of energy between the capacitors and the coil. Now, you know what I want to do? I'm going to hook up these an incandescent load, because what I want to do is I want to test in a different way before I go to bed. So let me turn this off. Turn this off. So let me go from. So now we're going from the output of the coil to a resistive load, from the resistive load to the capacitor load. Okay. Now I've got an LRC circuit instead of an LC circuit. So I want to see what happens, and I want to see. This is what I didn't do yesterday. I want to see if there's any way that this works better. It's going to be really hard to see the bulb. It's way in the back. I don't know if you can see it, but oh, it's dimly lit. Okay, so now let's see what. Okay, now look, we're still showing quote over unity, and let's go to our applications, because this should be true power now. Right, so output power, now the power factor is 0.6 and the input power is 0.7. So we're a little better now with a reactive load. So let's try to tune this. Where's my trigger? Okay. So what would happen? Okay. No, that's with. Let's try adding more resistive load. Look at that. We added more. Oh, we added less. Okay. Let's turn all these on. What I'm doing is turning on a bank of resistors. So now we have all these resistors in parallel, so we have a very, very low resistance. Now let's see if this is tunable. There we go. Look, now the phase angle is almost 90 degrees difference. Let's go back to application and measure. So look, let's take away some resistive load and see what happens to the power factor. So I'm just switching them one at a time here. Okay, now it's starting to go up. We're starting to get down to the last two. There's the last one. Now if I disconnect, there you go. See, power factor went up. And our light lit. Barely, but it's lit. So now let's turn it off completely. Now that's with basically nothing on the output. You see how it slowly takes some time for it to die down? That's because the bulb is dimly being lit. There you can see it now back in the corner. So if I turn it off, see it die, turn it back on, and it'll slowly start to glow. And if I turn 2 on, it's not enough. I can feel the heat, but it's not enough to light. Oh, there it's coming. Let's see if I can tune it a little. It's like just barely glowing. So we'll turn that one back off. Okay, so that's with it in series. Now, if I put it in parallel, I don't even think I'll get let's see, that's in series. So if I put this, and okay, that was in series. If I put this in parallel, right? I don't even think I can get resonance to happen in this instance. Actually, looky there. There's our light starting to glow. So that's not bad. Okay, so now now our current is a phase change. Now let's look at our analog meters. Oh, look at that. Output is like 0 volts. That's because we're lighting our bulb. Let's put on another light. What happens? Kill it. Let's try to tune into that. Look, we're actually tuning into that. That's pretty good, actually. Where are we at on input current? Oh, crap. Pretty high. We gotta be careful. So we're gonna heat up a lot of stuff that way. Now this is true measurements, okay? This is a resistance load, which is true power. Okay, so if we look here, power factor input's at 0.3. Power factor output's at 0.9. That's real power. Okay, so output power is 5 watts. Input power is 6.3 watts. Okay, but we want this power factor here, we want it to be close to 1. So let's see if we can actually try to tune it more towards 1. And now we're going the wrong way. factor on the input is actually lower. I'm changing the amplifier. I'm going to try putting in a square wave. Okay, now let's go back to a AC wave. Cranked everything up all the way. So let's try something. Let's switch back to series. Series. So we're going to go into the capacitor, then out of the capacitor, and into the load, and back into the... So now we should get some stuff back here. Let's try it. Whoa. I want to see the voltage go up. We've got 2 bulbs across it right now. Power factor is 0.5, output 0.9 in. What about, let's see. Let's turn on 1 bulb instead of 2. Okay, so let's turn back on 1. We're getting more transfer with more. We can't really see what we got though. This is a square wave. I kind of want to hook one of these up in series instead of parallel, but can't do that with what I got right now. Alrighty, there's your over unity effect. Can you see it? We are currently, even the scope doesn't lie, right? Okay, look at that. True power output is 34 watts. True power input is 10 watts. Okay, but you gotta look at the power factor. 0.7, 0.8 in, and 0.65 out. That's actually not terrible, but not great. Anyway, but the meters on the desk, right, the analog meters there are showing 1 amps in at 28 volts, 26 volts, something like that. Actually, I'm sorry, 48 volts. And 1 amp. Okay, and then we're showing like about 80 volts out. And 1.25 amps. So, and we got our little light bulb lit back there. It's actually lit a lot better than some of the other ones. The coil is staying cold. So that concludes my tests for today. Thank you for watching. Have a nice day. I'll speak to you guys another time. Let's shut it down. Shut it down. See, it's clipping no matter what. That's a weird waveform. Alrighty then. I'll speak to you guys another day. Oh yeah, it is the wrong day, isn't it? Oh, peace and love. Have a good night.